I am Dina. I am a developer relations engineer with Google Cloud. And our talk today is measuring DevOps. What does velocity mean in open source? And specifically, we are going to be looking at the DORA metrics and how they apply to open source. And today I have Sophia with me.
Hi, my name is Sophia Vargas. I'm a program manager within Google's open source programs office. I'm also an active member in the chaos community. And across both of those spaces, I work with project leaders inside and outside of Google, discussing how to implement project metrics around health and sustainability.
Awesome. Okay, to get started, let's start with definitions so that we are all on the same page. To begin with, what is DevOps? There are a lot of different definitions of DevOps, but the one that we are going to be using is an organizational and cultural movement that aims to increase software delivery velocity, improve service reliability, and build shared ownership among software stakeholders. In other words, DevOps is a way of using communication and automation to increase velocity and reliability, to make users happy. And that brings us to DORA. DORA is the DevOps Research and Assessment team. In over 7 years of research, they identified 4 key metrics to predicting organizational success. And I want to point out that these are predictive metrics, which is a stronger relationship than correlation. And roughly, these metrics fall into speed and stability. On the speed side, we have deployment frequency and lead time for change. And on the stability side, we have change fail rate and time to restore service. Now, a lot of people think that these are either or metrics. However, what we find, what the research has found, is that organizations that do really well in speed also do really well in stability because the capabilities and the systems that you put in place to improve speed go hand in hand with stability and vice versa. So with that in mind, we're going to dive into the metrics. The first one is deployment frequency, which is how frequently a team successfully releases into production. For example, daily, weekly, monthly, yearly. Now, a common mistake that I see here when people start thinking about this metric and they start trying to calculate it is easily confused with deployment volume. And so what we see is people looking at like the average number of daily deployments, which is a little bit misleading. So for example, say in the course of a month, you have one day where you do a deployment. Maybe it goes a little wonky. And so then you do 30 more deployments to try to fix all of the mistakes that happened with the first deployment. And then what we have is we have 30 deployments in this month. And when we average it out over the month, we're like, hey, look at this. We have an average daily deployment of 1. We're deploying daily. No, you are deploying monthly. So what we want to look at is how frequently we're deploying, not how much we're deploying. So next we have lead time for change, which is the median amount of time for a commit to be deployed into production. And what we want to think about here is taking a step back. This is how quickly can we develop a feature and for it to reach our customers? And so we start with the first commit because that is the first signal that we have that is consistently available. And then we end when it is deployed into production and available to the customers. The next is change fail rate, which is the number of failures per the number of deployments. So, for the rate, we have our denominator, we have our numerator. Our denominator is the number of deployments to production, and our numerator is the number of failures in production. So, for example, if you have 4 deployments in a day and one of them causes a failure, then that would be a 25% change failure rate. And a failure can be so many different things. It could be actual like 500 errors, but it also could just be like your service really slowing down and having very slow response times. And essentially, the definition of the failure is really up to each team, each organization, but it's really important to write that down and be consistent with it over time. So next we have time to restore service. So for a failure, this is the median amount of time between the deployment, which caused the failure, and the restoration. And we want to look at the actual deployment of the failure rather than the detection of it, because It's not always available, but if it is available, this tells us something about our system. So if there was a failure that is affecting our users for a month, but we just found it yesterday and we fixed it really fast once we found it, well, if you just looked at the time of detection to the time of restoration, we would think that we were doing a really great job and our users were having a really great time. But for all of these metrics, we're really considering how our users are experiencing our software delivery. And so that is why the time of deployment is a better place to start that clock, because, for a month, maybe these users were suffering. And so we have to step back and think, how do we improve our system so that we're able to better get that information in and to act on it more quickly? So again, these are our 4 key metrics. And the reason why these are helpful is because they help us benchmark against these metrics in the industry, and it helps us understand where our bottlenecks are and where we can focus our efforts for improvement where it's needed most. So those are the 4 key metrics. And now we're going to start thinking about, what does this mean in open source software, which is a little bit different from all of these enterprise examples we've been talking about. Sophia?
Thanks for that overview, Dina. And the first thing I do want to talk about is your last point. What is different here? And I wanted to start with your initial definition of DevOps and understand how this can be interpreted in the realm of open source projects and communities. And the first assumption that we want to discuss is DORA and DORA's research focus has been around software development teams. And there's an implication that these teams work for companies. And while these teams might have some dynamic membership of new people coming in, people changing roles, teams changing function, there's still this idea of shared ownership and incentive because everyone works for this company. Now, in an open source project, there is no such delineation. These populations are highly dynamic, and not only are they dynamic, but expectations and incentives are highly variable. We have some volunteers, we have some paid staff, and we have other people that have uncertain amount of time and commitment to the project and may come in and out of the space. So this idea of what the organization is highly flexible and can be interpreted in various ways depending on your project. But within that and the other goals in DevOps, there are definitely some commonalities in goals, say around improving and delivering reliable and stable code, around creating a sense of shared ownership and culture. And I'd say this latter point is even more important for project leaderships because there isn't that company incentive bringing folks together. They have to foster this collaboration and culture within their extended community to ensure that folks feel engaged and are willing to take on shared ownership of the project. I would say one key difference of this focus on DevOps in the open source space is around software delivery velocity. And not to say that projects don't have this goal, but a more common goal amongst open source projects is this idea of sustainable productivity, where you're thinking about reducing the chances that your contributors or your maintainers get overworked and they burn out and then they leave the project and then the project is now at risk. So I wanted to think about how we could interpret the 4 key metrics for open source projects, starting first with deployment frequency. Depending on your project, you may or may not have a set release cadence or schedule. So here I would say pick the metric that is most reliable and easy for you to measure. Just make sure you're consistent on measuring it every time you want to benchmark yourself and improvement against this goal. But looking at, say, release, commit, or merge frequency in the project, thinking again about that highly dynamic population. Another good thing to monitor for open source projects is not just the activity, but also the distribution of that activity between contributors and maintainers. And this can be a great way to monitor what portion of your community is doing the most amount of work and how is that work being distributed, and is the current distribution a sustainable model, or do you need to, say, invest more in encouraging new contributor growth? For lead time for changes, In a similar realm, you can look at median time for a commit to be reviewed and merged. And from the perspective of open source metrics, I thought this was a great metric to look at contributor experience. In fact, there's a number of projects I've worked with that are actively monitoring this metric as a way to gauge what is the experience like for the average contributor. If they submit a pull request and it lingers for a long time, or all of their pull requests end up getting rejected, then that's not a very good experience and isn't a great incentive for them to stay engaged in the project. So we highly encourage looking at this median time for review or merge of a pull request, but also looking at how that time changes for, say, established contributors that are known entities in the population versus net new contributors who don't have the same connections and can't reach out to individuals they know. They're very much on an island here. So this could be a great way to monitor what that experience is like for net new contributors. This metric can also be an indication of issues in your decision-making process inside your project governance or project structure. So say you start with a very small project. There's only, say, 1 or 2 people that are making technical decisions in the project. But as the community grows and scales, having the same group of people review all of the changes can lead to bottlenecks and slow down that experience for net new contributors to get their pull requests reviewed and submitted into the project. So this metric could also be an indication that you need to think about your current decision-making process and governance model in the project. Has your project gotten to a large enough point where you need to start think about distributing authority and decision-making into other areas of the project? Now, for change fail rate, here we're talking about open source code and not a service. And so the idea of serviceability is not like for like when we compare this with open source projects. But I still wanted to look at these metrics and see what else we could use to measure our overall code and stability within the project and community. So one thing you could look at for change fail rate is test fail rate. Some projects have robust test infrastructure, so that could be something that you report on. Other projects do not. Maybe they're running it on a handful of laptops, and that might not be consistent year over year. So maybe a better indication of change failure rate is looking at, say, the issues that are surfaced after a prominent release and tracking how many bugs are popping up, the kinds of bugs that are popping up, and that can give you a sense of your QA process and release quality. For trying to restore a service, you could look at the median time it takes to address or fix a bug or an issue, but maybe a better measure for a project might be understanding the median time it takes to communicate that there's been a disruption in the project. So I've worked with a number of projects that don't have any sort of process here. So maybe if you're in that boat, the more basic metric is, do you have a process at all that allows you to communicate to your user and contributor population that there's some kind of issue, service disruption, or a vulnerability that's come through in your project? The last point I want to make is a bit divergent from the DORA focus. And this comes back to that first assumption that we discussed around understanding how we define the organization. And with this, I want to mention that within open source, measuring the project's health and productivity around the code base is just as important as monitoring the health and sustainability of the community and population that maintains that project. So I highly recommend looking at metrics that can continually measure the health of the community around your project. So that could be looking at your contributor growth over time, your retention rate of existing community members, how long it takes for a new member to onboard or a contributor to become productive, maybe time to first commit. Maybe looking at conversion rates from your user community into your contributing population. And all of these metrics could also be an indicator of your documentation quality and completeness. Is it possible for a net new contributor to review your documentation and know how they can contribute and become productive without too much overhead? The last point I want to make is on resources. So I mentioned up front that I work with the CHAOSS community. This is a project that talks about open source metrics. We try to create a standard language and propose a set of metrics that anyone can use to monitor things like project health and sustainability. So if you're just starting this program and you would love a place to get ideas and read about how other people have implemented metrics around the open source project, this is a great place to start.
Thank you, Sophia. So now that we know about the metrics and we know why they're good and what we want to do with them, we need to start thinking about how do we measure them? Now, the DORA research used surveys, which is great if you have 7 years and thousands of teams and just a lot of data points. However, if it's just you are subject to bias. And for instance, you might be suffering from recency bias. And if you just had a really big failure and it was in TechCrunch and everybody's talking about it, you might have this like outsized idea of your change failure rate that is not reflected in the system's data. And so whenever possible, we want to use systems data, because the good news is you have all of the data that you need to calculate these metrics. The bad news is it is in 1,000 different places, which is why we started the FourKeys Project. Now, the FourKeys Project is designed to automate the collection and manipulation and calculation of the 4 key metrics. And the challenge that we faced when designing the FourKeys Project was that developers use many different kinds of tools and environments to do their work. So how do we capture the data from all of these different tools? And how do we account for tools that we don't even know about? And our solution was to create a generalized pipeline that takes in events via webhooks and ingests them into a database. Now, the default installer is designed to work with BigQuery, but you can sub in any SQL database. And data mapping is really the key of this project. And the events raw table is, in essence, a DevOps log. So as the data comes in through the webhook and goes through the ETL system, everything flows into this raw events table. So it should contain every single event related to development, deployment, and incident management. So when in doubt, stream it into the table. You don't know when you're going to need it. So from that raw events table, we create these 3 derived dimensional tables: changes, deployments, and incidents. And with these 3 entities, we can calculate our 4 key metrics. And the reason why we're doing this in SQL is so it is very easy to update the scripts and include or exclude different events from, for instance, your incidents. If you are classifying some events as incidents based on a label or maybe a certain kind of error in your logs, then you would include it in incidents. But then if you change systems, you might want to update that a little bit differently. And this is really easy to do when you are just changing your where statement in SQL. It is very difficult to do if you're trying to go back in time and pull in events that you didn't pull in to begin with that may or may not be in these different tools still. So this is why we do everything downstream, so that you can calculate and change the definitions so that you can compare apples to apples over time consistently. That brings us to the FourKeys Dashboard. This is the dashboard in the project. We actually have a new template in dark mode coming out soon, so it's going to be very fun and very exciting. And around the corners, we have these kind of daily running logs that show you how you're performing, like today and yesterday. And the thing that's nice about this is it's kind of like an early warning system of which direction you're trending. So if you have some kind of experiment in place, like maybe you had a lot of failures on your releases and now you're doing these end-to-end tests, you would expect to see your change fail rate, trending down. And so this is a really good way of giving early feedback if you're going in the right or the wrong direction. And now down the middle, we have all of the metrics bucketed over the past 3 months. So these are really kind of macro metrics. You want to step back and understand, what does this mean for your organization over time? And so that's why we have these big buckets. And they are bucketed according to the DORA research. Now, this is from the State of DevOps report. and there is a new one coming out soon. So these buckets might change a little bit. And when they do, we will also update the FourKeys project. But I would take this with a grain of salt because you might not have the same resources that some of these elite performers have. But what it's good for is to understand where you most need to invest effort into improving your DevOps so that people who are contributing to your project can have a smooth onboarding process and your users don't run into a lot of problems. With that, I welcome you to get started and get involved. You can try out the FourKeys project, you install it, it's on GitHub, you just run the setup script, it's with Terraform, so it just does a lot of magical things. And we also have this blog post if you want to read more about it. And finally, if you want to ask questions or just want to chat, join us on Slack. And with that, I will say thank you very much. And thank you, Sophia.
Thank you, Dina, and thank you to our listeners.